So for the upcoming lunar eclipse on Friday the 14th of March, I'm going to be over in England, and I'm going to be in the north of England, and I'm thinking that I might chance my arm and see if I can capture this lunar eclipse over in the middle of the country somewhere around here. And a couple of interesting things. The total eclipse starts 1 minute before sunrise, and the moon sets around 7 minutes after sunrise. So there's a tiny window of opportunity, clouds permitting, to photograph a setting, totally eclipsed moon with the sun rising behind me. And that's that phenomenon known as the selenelion that I covered in the other video. Question is, what are the clouds going to do? So what I thought I would show you is some features in PhotoWX, the photography weather site, that can help you understand the potential impact of clouds on your shoot. You can access PhotoWX up here directly. Just click the WX link, and I've opened it in this other page. And there's the pin, more or less in the same place. Now, I don't have weather forecasts available out as far as next Friday yet, but I'm looking at tomorrow morning, Monday the 10th of March, and I'm in the auto time zone, so it's picked up that I'm in the Europe-London time zone. So these are local times for up here in Cumbria, Northumberland area. And you can see that I have clear skies. I have the UK Met Office 2-kilometre model selected. I have the multi-cloud forecast loaded. And just to quickly recap what that shows you, it basically combines the low, medium and high cloud forecasts into one and uses colors that let you just look and see directly which layers are present without necessarily being able to see through them all. The colors just reveal. So the sort of greeny yellow is the high cloud, the magenta is medium cloud, and the turquoise is low cloud. Then you get these three combinations of possible layers. High and medium is salmon pink. High and low is sort of pale sage green. Medium and low is this lilac color that we're seeing down here, for example. And then if it's just clouds at every level of the forecast, it reduces to this gray, cloudy gray, which is what we're seeing up here out over the North Sea. So here it's looking like clear skies, which is great. The first question to ask is, do we need to worry about whether these clouds are going to be visible from the pin position? So I want to show you one relatively new tool here. This is this cloud level indicator. And when you enable it, it does a couple of things. This is the first of two things that I'm going to show you. It draws circles of distance around the red pin position, and each circle corresponds to clouds at a certain height above the ground. So if you hover the mouse over it, here you can see it says clouds 1,000 feet above the ground can be observed up to 26 miles away. So that immediately tells you that, for example, those clouds that are just to the north of the red pin position are definitely going to be visible if they are 1,000 feet above the ground. How do you know what height above the ground these clouds are? Well, in the definition you've got here, it says that low clouds are between 0 and 2,000 feet above the ground, 2,000 meters above the ground. 2,000 meters is about 6,000 feet. So just hovering around these circles, a cloud that's 6,500 foot above the ground could be seen from 88 miles away, which, as you can see, is quite a long distance. Now, these are the absolute limits of visibility. The way it's calculated, it accounts for refraction. It assumes that you have crystal clear atmosphere in between you and the cloud that you're observing. And the distance is calculated so that if you looked at it in these ideal conditions, you would see about half a degrees worth of cloud on the horizon, sort of more or less the same as a rising moon or a rising sun. But bear in mind that typically this is as good as it gets. It's not as bad as it gets. You may be able to see less than that, based on visibility, and you could load the visibility forecast to check that out as well. And you could correlate what the visibility forecast says with what the cloud forecast is saying and what the theoretical visibility is. But what we conclude from that is that yes, we do need to be worried about these low-level clouds in anything up to the first, certainly the first couple of circles and probably the third. There's one more thing that you can do though. First of all, I'm going to turn this off for a moment and I'm going to enable the moon. So here's the moon. You can see that the moon is setting. It's coming down 5:43 a.m. in the morning. We're a little bit before sunrise, so we're still in twilight. And tomorrow morning, the moon is setting quite far to the northwest up here. So the question is, are these clouds going to interfere with moonset? I think you can already predict that the answer is yes, they will interfere with it, based on the circles of visibility that we looked at. But when I have the moon enabled here, and then I also enable this tool, it shows you some additional information. So here what we have is the moon azimuth line, this line here, that's the direction from the pin to the moon. And in addition, in colors that match the different low, medium, high layers of cloud, it shows you the span of distance away from you, the observer at the red pin, at which a low cloud will block the moon at its current altitude above the horizon. And so you can see that, yes, right now this cloud is, if it were present, if the forecast is correct, it will block your line of sight to the moon. Medium cloud in this range will block the moon as well. If there were any high cloud underneath this segment of the line, that would be blocking the moon as well. There isn't any high cloud there, so you don't need to worry about it. But if you see the yellow segment and then you see yellow or one of the colors that includes high cloud, for example, the salmon pink or the sage green, you would go, that's going to block my view of the moon. So that's what these are doing. If you watch, I'm just going to reverse a little bit in time. And as I'm going backwards in time, the moon is getting higher. And the lines shorten and come closer to the red pin. And hopefully intuitively that makes good sense, because as you have the moon or the sun higher in the sky, its propensity to be blocked by a sheet of cloud is reduced. The impact of the thickness of the cloud layer is much less. And so the lines get shorter and they become closer to you. So that when you, for example, if you were to reach a point in time, say here, where the moon is really at its highest, the lines are very short indeed, and we got clear skies. So you would conclude from that, yes, I can see the moon, no trouble at all. But once we're getting down here, back into, we've got some cloud has moved in, the moon is much lower in the sky, and it's going to be blocked. So you can use this in the days, 2 or 3 days ahead of the eclipse, to check the cloud conditions and to check the moon visibility to see if it's something that's going to play ball for your plan or not, according to the forecast. So bear in mind you can do the same for the sun. So I'll switch the moon off, switch the sun on. I'll come to, let's say, around 8 a.m. here, and there's the sun. And unfortunately, we're blocked by clouds. Again, you can see that pretty clearly. I'll turn that off. And it's pretty, when the clouds are overhead, you know it's likely to be blocking. But say, for example, the sun were around here, would it be blocking? Low cloud, probably yes, but what about high cloud? This tool can show you that a little bit more clearly. Let's just try coming up to, say, I don't know, 3 p.m. There we go. See what the forecast is doing. And again, it's England, the clouds have moved in and things are blocked. But hopefully this has given you a good sense of how to use this cloud observability and sightline analysis tool to plan your photography. Thanks for watching.